All right, here we have a question regarding the matrices and regarding the orthogonal sets here. Ask us to verify that the span of u1 and u2 is an orthogonal set, and then find the orthogonal projection of y onto the span of u1 and u2. So we have vector y, we have u1 and u2 vectors. So to verify these are the orthogonal set, first of all, we have to make u1 times u2 in a dot product, and if the answer is 0, that means it's orthogonal set. For this, I have this calculator, an online calculator called Matrix Calculator, and it's in matrixcalc.org-en. You can find that, and it's very useful products here. So here we go, and I want to make it like that. I can see it better. We have to make u1 times u2. So in this order, we have to make the transpose of u1. The transpose of u1 is going to be in one row, 3 columns, because this is one column. It's going to be easy one, so it's going to be 5, 2, 0, and make it times to u2. The u2 is going to be by itself, so I'm going to make -2, oh sorry, -2 times -5 and 0. So okay, yeah, here the answer 520 times this is going to be 0. So the answer is 0, and that means this is a orthogonal set. And as you see, my MATLAB accepts the answer. And now here we want to find the projection y. That's gonna be a little bit more work to do. For this reason, we need to make y times to u1, then divide this answer to y times to u2, and the whole answer make it times to u1, and then we go ahead plus it. So plus that the whole thing on the u2, and then we gotta find the projection y. So the first thing first, we have to make y. The transpose of y is 7, 6, -2, and u1 is 5, 2, 0. Here we have 47. Let me open the Word file. Probably helps to remember everything. That's a little bit slow, you know. Get blank document. So here we have what was that? Let me see it again. This was y times y times u1, which is equal to 47. Alright, so now we go next step, make y times u2, which is -2, 5, 0. Boom, the answer is 16. Y times u2 is 16. Okay, now u1 times u1. and u2 times u2. First we go u2 times u2. The transpose of u2 is negative 250, and make it times them. That's 29. So we have u2 times u2 is 29. And then we have to find the u1 times u1. So u1, to transpose u1 is 520, and the actual vector is 520. Transpose 29 u1 times, oh sorry, times u1 is equal to, I keep forgetting that, oh wait, it's here, it's 29, so both are 29, right? That's gonna be interesting. So y times u1 is 47, so we have 47 divided by u1 times u1 is 29. This is the first step. And the other step is y times u2 is 16, that divided by 29 again, and the whole thing, I'm gonna put this in the parentheses, that way you know that the whole thing is gonna be times u1, and here is again the whole thing, it's gonna be times u2. Okay, how to find this? Now we're going to make them. Okay. What is that? Okay, we have, this one is 520u1, and make it multiply, and it was 47 divided by 29, so we make it 47 divided by 29 and find this multiplication. It's gonna be this number. We write it down for the moment. I'm writing it down on my paper because it's gonna be faster. 2, 35, 29, 94, 29, and 0. And now we're gonna make u2, which is negative 2, 5, 0, and that multiplied, I think it was 16 by 29. Double check again. Yes, 16 by 29 multiply, and gonna be this number, negative 32, 29, 80, 29, and 0. So now we have to add these two numbers, this number and this number, to find these projections. So for that reason, I still can use this. The u1 was 235 over 29, 94 over 29, and 0. And the other one, which we found it from the u2, is negative 32 divided by 29 over with 80 by 29 and 0. So we make this a plus b. find the answer. It's 760. So you come here and test this number if it's works. 760, and let's check the answer. Boom. Yes.